Hello, welcome to the fourth and final video of the 9th chapter of the Crystal Clear Electronics videos. Ambrus is here with me, and in the previous video we saw how the microcontroller is connected to the programming device. Now, it's time to connect the programmer to our computer and load the program onto the microcontroller to flash our LED.
Thank you, Peter. First of all, let's start with the power supply. The solution will be simple because one of the adapters can provide a stable 5-volt power supply for the microcontroller. Similarly, like the previously learned 7805 circuit, it generates the 5-volt power supply required by the microcontroller and connects the voltage to the right pins of the microcontroller through the breadboard. We can connect the supply voltage to the input of the supply circuit in several ways. The point is that the voltage has to be between 7 volts and 20 volts. The ideal range is the 7 to 12 volt range. We can connect the DC adapter, if its plug is proper, to the J2 marked plug. Or we can connect a 9-volt battery to the green screw terminals marked with J1. These cases have their disadvantages that there isn't a current limit in the system, an unwanted short circuit or badly connected components may damage something. The ideal situation is if we can provide voltage for the J1 terminal from a laboratory power supply, and we set the current limit of the power supply to a small value at first, about 70 to 100 milliamperes. When we connect the power supply, we have to watch for the polarity. The adapter also contains a serial diode on the supply input, so in case of inverse connection, current won't flow, nothing will be damaged, while, in case of correct polarity, a green LED will light up on the adapter. Which solution are we going to choose?
The power supply could be connected to the green terminal J1. We set the voltage limit to between 7 and 12 volts and the current limit to between 70 and 100 milliamps. But we prefer to just plug our power supply into the J2 connector. It will be 12 volts and the current limit will be fine.
Peter, please plug the connector into the outlet and the other end into the adapter, which will then pass the power to the microcontroller. What do we need to see? How can you check that things are done correctly?
I connected it, and we can see that the green LED lights up, meaning it gets power.
So the green LED shows us that everything is alright with the power supply. Our power supply works properly. The USB connector on the adapter will be used in later parts of the curriculum. We won't need this time. Make sure that the section of the pin row next to the USB connector is not connected to anything on the breadboard for the time being.
Let's connect the LEDs and make them flash.
In fact, we have already connected one LED. Let's connect an LED and the 330 ohm resistor between the microcontroller's PA0 pin and the ground, so that the LED lights up later when 5 volt appears on the pin. In case of reverse polarity, the LED won't light up. You can also see the schematic. The hardware part of our device is now complete. Now comes the important step of loading the firmware that will make the microcontroller work as intended. But what is a firmware? The microcode that works with the microcontroller is called a firmware.
To load the program, the Atmill company provides us with a development environment that can be installed on the PC. The development environment is the software itself in which the program is written. This is where we write the instructions to load it onto the microcontroller. I'm going to connect this together.
You have already seen in the previous video that the programmer is connected to the adapter with the JTAG connector. And now, you take the step of connecting the programmer itself to the USB port. Am I saying it right?
Yes, indeed.
During the curriculum, We will use the version v6.2.1563 of the Atmel Studio, which can be downloaded from the website from the curriculum. Microchip continuously develops the software. If you feel like that, you can use the latest version of the software too. However, in this case, we cannot guarantee that the example programs will run without errors because of compatibility issues. In case you have problems during downloading or installing, you can find a detailed guide on the curriculum's website at the actual part.
I feel like the time has come to download our software, or in other name firmware, to our microcontroller.
Yes, but for now, we won't write the code. We will use a pre-written code for simplicity. The project that contains the first software compressed can be downloaded from the website. Understanding this software code and writing our own code will be started only in the later parts of the curriculum. However, now we'll learn how we can upload the code to the microcontroller. After we unpack the file, open the CE9_1_LED_blink_delay Atmel Studio solution file. Make sure that the microcontroller's pins get the right supply voltage and the programmer is connected properly to the microcontroller. Connect the programmer to your computer. If that's the first time you program the device, definitely choose the Tools menu and then the Device Programming option. Let's set the parameters of our system here. From the Tool menu, we should choose the Atmel ICE. This is the type of our debugger. As a device, let's choose ATmega16. This is the microcontroller itself, which we have studied before. For the interface, we should choose JTAG. In the previous video, we briefly talked about the fact that the connector is also standardized. That's what we're setting up here. Then, press the button Apply to read some data directly from the microcontroller. We can see the default setup of the microcontroller if we click on fuses inside this window. Here, let's find the clock signal frequency with the SUT-CK-SEL word and change it to the 8 MHz clock signal from the internal oscillator. Don't change any other values. In order to make the change take effect, click on the Program button, then close the Device Programming window.
The pre-written software can be easily loaded to the device if you first click on the Start Debugging, then the Stop Debugging buttons. Everything is ready, so I will open it now.
Awesome, so we can see that we made everything right. Our computer doesn't throw any error messages, and our LED blinks with a period of 2 seconds. This is given out because, as you will see in the code, there is a delay of 2 times 1000 milliseconds. After that, we are free to understand the programming better and start playing with other peripherals. Before we say goodbye, let us share 2 practical pieces of advice. One is to never use accented letters or special characters in the name or path of files. These may cause the firmware not to load on the microcontroller. Another tip is to always take small steps while developing the program. If you always make small changes from a working version, it'll be easier to spot any bugs in the new parts. This is true not only for the code, but also for the hardware. Do not try to add 3 new peripherals to the microcontroller at the same time, because you will probably fail the first time. But perhaps Peter has a better understanding of this, since he spends most of his time programming.
Yes, save everything and test it to see if it's ready after every small change in your program. This was the 4th and final video of the 9th chapter of the Crystal Clear Electronics videos, Microcontrollers I. Remember, we have just opened the door, and when you enter it, a whole new and colorful world opens up. The beauty of programming is that only your imagination limits what you can achieve. We hope you found this part of the curriculum interesting and useful.
Don't forget that you can learn more about the basics of programming and microcontrollers in the following videos.
The curriculum can be downloaded in PDF format from crystalclearelectronics.eu and in Hungarian from kristálytisztaelektronika.hu. You can find the mobile application for Android and iOS platforms under the same name. You can also follow us on Facebook for the latest news and see you soon in the next video. Bye bye.
Goodbye.